Alright, in this lesson, we are going to look at time series analysis. Now, this is actually linked to bivariate data. Think about it as time series analysis is where the dependent variable is time. That's x-axis, and we have got data that we can analyze. So, by the end of the lesson, you should understand that time series data is concerned with the collection of data over a period of time. You should be able to plot a time series data on a Cartesian plane manually and using ClassPad, which is called a time series plot, and be able to describe the time series plot. Now, let's have a quick look. What are time series data? It is actually a collection of data over a period of time. For analysis purposes, the data should be collected and recorded over a regular time interval. Some examples: rainfall. It could be daily rainfall data, monthly rainfall data, or annual rainfall data. Temperature and blood pressure of a patient in a hospital could be hourly, half an hourly, or maybe for hourly or 6 hourly. And share price is a daily, or sometimes it's actually hourly you're looking at. So the time series plot actually displays any patterns exhibited by the data over time. It can be used to make comparisons, predictions, and draw conclusions. One of the examples that I'm showing you is rainfall. For example, this records the rainfall in millimeters in the month of July. We don't know what year, we don't know where it is. However, we can see that every day in July there has been rain, and the data recorded is the 24-hour rainfall. Alright, now you can see that the x-axis in this case is time. It's always time, it does not change, and it must have equal spacing. Alright, the next thing that you need to think about is the y-axis. Y-axis is the data being analyzed. We are analyzing the trend of the rainfall for July in this case. Now, you plot the data as dot, and then you must connect each point with the previous and upcoming points. Alright, so make sure that you use a ruler to connect the data point. Next, what we're going to look at is some real-life applications. Climate data is typical. We use climate data. We can use it to investigate climate change. Share price, thinking about whether we should invest, buy some shares or sell the shares. Population for infrastructure development. Again, if you look at stream flow, it's the impact of climate change, flood mitigation, and so on and so forth. Monitoring the health of a patient, blood pressure. Sales data is important. The sales amount and the earnings, we can predict the earnings. And computer price index data, inflation, and so on and so forth. So it actually used a lot in the real world. Now, this is a typical stream flow. It's actually not typical. It's a recorded stream flow into Southwest Australian dams from 1911 to 2018. And you can see that the data is fluctuating. There's up and down, peaks and troughs, and also you can work out averages. For example, averages between 1911 to 1974, and so on and so forth. Once you work that out, you can see that there is actually a drop in stream flow flowing into the dam. Useful information. Now, for a time series data, we need to look at the components such as the secular trend, the cyclical variation, irregular variation, or the seasonal variation. Right? Let's look at these 4 different components. First one is called the secular trend. It's the long term or the overall trend of the data. To make a decision on the secular trend of the time series data, you must make sure that there's enough number of observations in the plot for an overall trend to be identified. So for example, this one over here on the left is actually a positive secular trend. Think about that as in terms of the bivariate data. It's actually positive, right? You can feed a positive trend line. So it is positive secular trend. Whereas the sales in the second graph, which is the graph on your right, is actually negative secular trend. You can see that the slope is negative. So we need to think about how we describe positive or negative secular trend. Then seasonal variation or pattern. It is periodic movements which are related to short-term time intervals, such as quarters of the year, months of the year, days of the week, and so on and so forth. You can really identify this by the peaks, which is the highs, and troughs, which is the lows. The highs and lows actually occur at regular intervals. We need to be able to identify the period of a seasonal pattern, time it takes for the cyclic pattern to repeat itself. Now, let's have a look at this graph. Why do I say it's a seasonal variation? You can see that x-axis, the quarter, is quarter 1, quarter 2, quarter 3, quarter 4. And y-axis is the profit. You can see that quarter 1, it's about maybe 3,000 profit. Quarter 2, maybe 5,000, 6,000, and then followed by about 3.5, so on and so forth. But there is a pattern here. This is a trough, and this is a trough, and this is a trough. And the peak, I'll show you in a few minutes. So what you need to do is identify the peaks or the trough. All right, here I say that there are 3 seasons. The period is 3 because you've got period 1, 2, and 3. And then repeat itself again, 1, 2, and 3. This is based on the peak. Now, if you look at the trough, if we start from here, 1, 2, and 3. Back to the trough again, 1, 2, and 3. Back to trough again, 1, 2, and 3. So therefore, you can see the pattern emerging. You can see that there's a 3, the period here is 3 quarters, which is 3 seasons. So every 3 seasons, it repeats itself. So to identify it, either circle the peaks or the trough. Okay? Now, the description for this is an overall increasing trend, and there is a strong seasonality, and the profits are predictable as they are calendar related movements or quarter related movements. All right, so now let's have a look at the cyclic pattern or cyclic pattern. It's a long-term fluctuation which are not regular. Peak and trough, we can observe it. For example, these 2 are the peak, these are the trough, but they do not occur at regular intervals, and this generally is long-term. All right. Note, the occurrence of peaks and troughs can be predicted for seasonal pattern, but not for cyclic pattern. So you cannot see it repeating itself. Although you know there is a pattern, but it's over a long term. Seasonal is actually over a short term. So here you can describe the time series data plot exhibit an increasing trend and is cyclical. Now, irregular or random pattern, the dots or the plots are all over the places. It's unpredictable and is short-term variation. Now, what I would like all of you to do is think about plotting this graph. Pause the video for a while and think about how you could construct this time series graph. But before you start, let's have a quick look. You've got time period January to March, April, June, July, August, October, September. So each one can represent a quarter, which is 3 months. All right. So at this stage, we are plotting it as time period January to March 2014, April, June. In actual fact, when we start analyzing the data, we may have just quarter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Now, you should identify the maximum and minimum, and then you can work out what the scale is. And then you should be able to describe the time series plot in terms of its trends, seasonal, cyclic, or random patterns. All right. I will guide you. This is actually the scale that I will use. The time in the x-axis, quarters, and then the sale in terms of 1,000. Now, like I say, it could be quarter 1, 2, 3, 4, and so on and so forth. All right. However, in this case, we are actually just going to use the month, right? So now, pause the video for a while and plot it. All right. This is my plot. I start off with the first dot. Oops. I could not get that right. Sorry. So let's think about what I'm going to do. I'll show you my first dot, second, third, fourth, and plot everything out. And then what you need to do is actually join each dot with straight lines. All right. Now, with this one, you can see that there's a seasonal pattern. I can pick the trough. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So, the seasonal pattern, we can describe this. The time series plot shows a slight positive trend because it is sort of going up. All right. Let me get rid of this line. All right, that's better. You can more or less see that it's going up with the seasonal pattern of period 4. I've shown you how to work out the period. You could have used the peak. It really doesn't matter. All right, I'm using the trough because in this case, it's a little bit easier to identify the trough. Just because this point here, I don't know whether it's a peak or not. All right, and you can say that it peaks during the January and March quarter. Now, what I would like all of you to do is grab your class pad out and start to think about how you could plot this. This time, the interval is 10 years. All right, 10 years. And then the population is in hundreds of thousands. And it will go all the way up to 2.0375000, which is approximately 2 million. All right. So this is based on the Australian Bureau of Statistics data. Can you use your class pad? Let's start to think about how we could plot this data. All right. The year would be the x-axis and the population would be the y-axis. Now, once you've got your class pad out, you should go to the statistic mode. The list 1 is actually the year. The list 2, you just type in the number. Although it shows scientific numbers, but if you tap on there, the number 2037000 will appear, 2037000 will appear in this box. All right, so it is okay. Once you type in, ClassPad will just show you in scientific notation. All right, once you've done that, I would like you to go to Set Graph, and under Setting, click on Stat Graph 1, and then make sure that the type is XY line. Of course, X-axis is list 1, which is the year, and Y-list is a population. Okay, and make sure that you tap on Draw On. Now, let's go to the next step. Once you put it in, tap on this column graph button, and you will see that a graph will appear, and that will be your time series plot. All right, that is the end of the lesson today, and I hope you understand what the time series data is, and you are able to plot the time series data on a Cartesian plane and using a class pad, and you'll be able to describe the time series plot. Time to do some homework and is listed in Google Classroom.